on the COVID-19 task force here. Our aims with Professor Anya Burns, Steve Powers, and the Chief Medical Officer is to raise collaboration and coordinate fluidly for what is now, for me personally, a second-round fight against this global COVID-19 pandemic. 3 weeks is once again, unfortunately, a very long and painful period of time for many of us in the course of a global outbreak. Since we last broadcast on the 28th of March, global numbers for 2,233,566 cases of COVID-19 around the world today. The majority of these cases are spread across 199 countries around the world and a handful of ships that are registered as international conveyances. The number of excess deaths directly attributable to this virus have also now gone from 27,343 some 3 weeks ago to more than 151,455 dead globally. This is a 5-fold increase. This new and clearly exponential growth of cases in recent weeks and the mortality figures have shown to be focused around new epicenters in Europe, including Italy, Spain, Germany, and France, the UK, and the US. I was senior author on the Lancet paper published together with Professor K.Y. Yuen on the 24th of January, where we identified and shared the first detailed phylogenetic evidence globally of person-to-person transmission within an early familial cluster of this novel coronavirus, which has now obviously become a globally impacting epidemic. Welcome everyone to this COVID-19 clinical NDT experience sharing webcast. Through the following 2 hours or under, we hope to share with you each now and one another our learning, our data, and experience on how to treat and diagnose and treat patients with COVID-19 infection. Before we commence though, may I propose a brief moment of silence once again to remember the 151,455 fallen patients. Each and every one of these is a family member, a loved one, a friend, or a colleague whom we have lost as a result of this horrible illness. We remember all our fallen colleagues and the healthcare workers who have now paid the ultimate sacrifice to battle with us on the front line. Thank you. May I please remind our experts and participating audience to now keep your microphones on mute unless responding to a direct question opportunity. This webcast is being recorded for playback, and we hope to protect the clarity of the audio signal for our listening audience today. Since a novel cluster of unexplained cases of pneumonia was first described in the last days of December last year, we have all now become very familiar, all too painfully so, with the characteristic clinical presentations of COVID-19. Patients are now consistently reported around the world to have found the same radiographic ground glass changes of a viral pneumonitis or alveolytic inflammatory responses on chest X-ray and lung CT imaging, normal or lower than average white cell lymphocyte counts and platelet counts associated with severe hypoxemia and or deranged liver and renal function tests. On the 30th of January, the Director General of the World Health Organization declared the current outbreak of COVID-19 a public health emergency of international concern and issued urgent temporary recommendations. The committee has since classified this epidemic as a global pandemic and asked the Director General to provide specific advice on these matters and, if necessary, to make new case-by-case recommendations in the review of rapidly evolving situations around the world. In light of this, the objectives of this meeting are therefore to maintain, enhance, and connect global experts and leaders in the fields of respiratory medicine, critical care, public health, and primary care, as well as infectious diseases management. We aim to uplift the capability of all healthcare providers to diagnose and treat COVID-19, to share our knowledge on how to control the current COVID-19 outbreak trends globally, and to help restore global economics and confidence to a normal track as quickly as possible so that we can help minimize further mortalities and impacts, and ultimately to save as many lives as we can. Sorry about this. The ongoing COVID-19 outbreak now clearly impacts every healthcare system across the globe. On March 3rd, the WHO announced an overall mortality rate of 3.4% estimated. This was based on 3,110 deaths among 90,893 confirmed infected individuals globally at the time. However, our latest global figures from noon today suggest a 20-fold increase in volumes from 6 weeks ago, to a new total of 2,200,033,566 cases with 151,000 dead, as mentioned, giving a new hospitalized and healthcare reported global benchmark mortality figure of 6.78%. Earlier epidemiologic data and death rates appear to have suggested a lower mortality estimate because of a greater model denominator that was thought to have included patients who are not yet hospitalized or were underreported due to unconfirmed testing. However, we now discover the converse to be true, as many deaths both at home, outside of hospitals and care homes is largely unaccounted for in most established reporting systems. We can therefore only assume that the actual death rate may yet be significantly higher than our global figure for mortality of 6.78% today. Whilst it is becoming clearer that the situation in China and Asia has reached a turning point, the WHO has kept the risk for COVID management at very high at the global level because of this. In the face of increasing isolation with growing potential for systemic insecurity, fear, and unilateralism, it is more important than ever now to use our common languages of science and medicine to unite together, and we really should spare no effort in sharing our joint experiences moving forward. Before we start, I would like to take this opportunity finally to thank our organizing committee, including Huashan Hospital, Nanshan Respiratory, the Journal of Thoracic Diseases. Once again, our sincere thanks to AstraZeneca for their superb and efficient support in coordinating such a timely and meaningful event in such a short time. To create this platform and to build the connections for constructive sharing actually represents the work of many individual clinicians, researchers, and colleagues who work tirelessly now around the clock and behind the scenes and on the front lines. We would like to take this opportunity, of course, to thank all of them and our colleagues in healthcare in this battle, in this critical battle against time and a common enemy. I would like now to extend a warm welcome and introduce you in turn to our key expert panelists, including Professor Zhong Nanshan. Professor Nanshan Zhong requires no introduction. He is the esteemed mentor, professor, and academician of the most prestigious Chinese Academy of Engineering. He is director of the National Clinical Research Center for Respiratory Medicine and former president of the Chinese Medical Association. He is also most famous, of course, because of his role in leading our fight against SARS back in 2003. Next to be introduced is Dr. Fernando J. Martinez. He is the chief of pulmonary and critical care medicine at Weill Cornell Medicine at New York City. He's professor of internal medicine and associate chief for clinical research at the Division of Pulmonary and Critical Care Medicine, also at University of Michigan Health System Ann Arbor, and is co-director of the lung transplant program there, as well as medical director. Professor Mike Grocott. Professor Mike is the professor of anesthesiology and critical care medicine at the University of Southampton here in the UK, and is a senior investigator with the NIHR. He leads critical care research with Southampton NIHR Biomedical Research Center and is an adjunct professor at Duke University in North Carolina, as well as University College London and King's College London. He has recently chaired the NHS England Rapid Clinical Guideline for Clinical and Adult Critical Care and COVID-19 response, and serves on NHS England's Clinical Reference Group for Critical Care. He is an elected vice president of the Royal College of Anaesthetists and is a former board member of the Faculty of Intensive Care Medicine here in the UK. Professor Jieming is the chief of respiratory medicine at Ruijin Hospital, Shanghai Jiao Tong University and School of Medicine. He is the president of the Chinese Thoracic Society, deputy president of the Chinese Physicians Society and Chinese Medical Doctors Association. He is the past president of the Respiratory Diseases Society and Shanghai Medical Association, as well as being president of the Chest Physicians Society in Shanghai. Professor Zhang Wenhong, you will recognize from previous webcasts. He's the professor and head of the Center of Infectious Diseases at Huashan Hospital and Fudan University in Shanghai. He is the chair and department head of internal medicine at Fudan University in Shanghai and is the leader of the local Shanghai anti-COVID-19 clinical expert team. He has extensive experience in the diagnosis and treatment of emerging infections. Dr. Gary Wong, finally, is our friend and colleague from the Department of Pediatrics at Chinese University, Hong Kong over the past 20 years. Dr. Wong has strong interests in different aspects of allergic and autoimmune disease, but in particular, he's interested in the epidemiology and environmental determinants of asthma and the related allergic disorders. He is an executive member of the Global Initiative for Asthma, the GINA guidelines, and is a committee member for the ISAAC on study of asthma and allergies in childhood. I would like now to hand over the floor to Pascal Soriot, Executive Director and Chief Executive Officer of AstraZeneca, to share with us a few words on how pharmaceutical companies can help the support and fight against global COVID-19. Mr. Soriot, please.
Thank you, Professor Zhong, and to all of you for the opportunity to speak with you today, but most importantly, for everything you're doing to fight COVID-19. And the work you're doing today, really sharing experience, is critical to the global effort to defeat this pandemic. In difficult times, the whole world should actually come together, and it's really energizing to see the healthcare community take the lead and collaborate with each other. So we're really grateful for all the experts like all of you willing to invest their time sharing their knowledge today. So the pharmaceutical industry worldwide has also stepped up to contribute in many different ways, and it really has been a team effort. We've seen companies work together without worrying about who owns what, and the information has been shared for everybody to use. So if I speak about AstraZeneca and how we stepped up ourselves, first of all, let me address what we've done as a contribution to the efforts of what I would call the heroes of today, the healthcare workers around the world who take care of patients. First of all, we bought 9 million masks very early in the epidemic, and we donated them to healthcare providers around the world. We've done that working with the World Economic Forum, the WHO, of course, governments and DRI in the US to decide where the masks should go, because we didn't know where the needs were. The great majority of those masks have been now distributed. The second thing is that many of our employees, medics or nurses and other people actually have volunteered their time. And our teams are supporting local communities through grassroots efforts. Many of our doctors work in hospitals, and we've put in place a program to allow them to do this and of course, continue to be paid by the company. Our teams have done many different things. For instance, in the UK, our organization have come up with the idea of refurbishing iPads and iPhones that we have donated to the NHS to enable people in hospitals to connect with their loved ones that cannot visit. That is, as you know better than I do, an issue for patients who sometimes die without seeing their families. Another example of what our people have done, and those are, I have many, many other examples. An Aussie employee in the US has developed a headband to help healthcare workers wear their masks day after day without hurting their ears. So we've had lots of, great ideas coming up from bottom up, from grassroots. We're also working hard to try and decrease the pressure on hospitals. You know very well, better than me, that the healthcare systems are stretched. And in many countries, we have partnered with technology companies and hospitals to develop digital tools that facilitate remote follow-up of patients who have chronic conditions such as asthma. We've advocated with governments for the temporary reimbursement of home injections of some products. For instance, in the US, you may know Medicare is now reimbursing the use of home administration of the so-called Part B products that are injectable products. And finally, we've also shared our knowledge with health authorities. For instance, in the UK and in Sweden, we've been collaborating with the health authorities in the development and the implementation of an antigen testing, and now we're working on an antibody testing. In the UK in particular, we've been collaborating with GSK and the University of Cambridge to set up a testing center in Cambridge, actually, that just started operating, and we aim to deliver 30,000 tests a day by early May. So this has been a really collaborative effort that was put together in about 3 days with JSK and the University of Cambridge, and nobody thinking about who was in charge of what. The team really got together very quickly, and we will deliver these 30,000 tests a day by early May. We are very much on time, and of course we are donating the resources involved in this effort. So let me now turn to what, beyond donations, what we've done internally as a company. First of all, as you can imagine, our absolute priority has been to maintain the supply of our medicines. We know very well that patients who suffer from an underlying condition such as asthma, hypertension, diabetes are more exposed. So we manufacture products for the treatment of asthma, COPD, hypertension, diabetes, cancer, and many other chronic conditions. So this really has been a key priority for us to ensure that our supply chains are not disrupted, so patients can continue to receive their therapies. And it may sound easy, but I can tell you it has been quite challenging because we had hundreds of our employees who had to be quarantined because they felt unwell, went home, and could not come back because our policy, based on CDC recommendation, was to stay home for 2 weeks. So we got to a stage where we had hundreds of employees unable to come back to work in our factories, and we didn't have the tools to test them, and so we didn't know whether they were infected or not, of course. But our employees have really done an absolutely remarkable job, and we've had no shortages. We were even able to supply the surge of demand for asthma and COPD inhalers that we've experienced in many countries. So what we have also done is we've supported our employees by protecting them. We use masks in our plants, not only in the GMP side of the plants, but everything around the plants. When people walk in there, they have to wear masks now. We, of course, have made hand sanitizers, and we had to manufacture them ourselves because they are in shortage. We are practicing social distancing, as you can imagine, and we're asking our office staff to work from home. We implemented childcare support for our employees who had their children at home in many countries where schools have been closed. As you know very well, for hospitals it's an issue, but for companies it's also an issue. People struggle with having to manage their job and also their kids who are at home. So we offered childcare support. We even offered in some countries homeschooling for the kids of the children of our employees. We've rolled out additional video conferencing tools around the company to enable our people to work at full capacity. And finally, we developed our own antigen testing that has started working, and we're offering this service to our employees at our main sites with, of course, the priority given to manufacturing sites. So we can now offer people the ability to test themselves to know whether they are infected or not when they have a doubt. Another important priority, of course, has been to think about the COVID negative patients. Everybody's so focused on COVID positive, and you doctors in hospitals, I'm sure, know better than me that COVID positive patients are the potential next issue, health issue. And for us, developing medicines, new medicines for severe diseases, a key priority has been to keep our projects going and our products, our new indications or our new products developed and approved. And of course, we've had to pause a number of trials around the world, but we've tried to keep going with trials in countries where the epidemic was less impacting. And finally, I'd like to say a few words about what we have also done addressing the disease itself and working on the disease and what we could do. And the way we've looked at it has been kind of threefold, if you want. Our view has been that we need to deal with the virus. We also need to deal with the immune response that is really killing patients in some cases. And finally, we thought, can we protect the organs during the course of the treatment? So we are working on a monoclonal antibody. We have very talented antibody engineers, and they're working on a long-acting antibody that actually can be used for prophylaxis, but also treatment. And we hope to have this in the clinic by the summer. We are the only company that has been able to develop an antibody for RSV in children. It's currently in phase 3, so we hope to do the same for COVID-19. So that's for the virus. For the immune response, we have launched a randomized study using our BTK inhibitor, acalabrutinib, which is approved in the US, Canada, Australia, a few other countries, and is awaiting approval in Europe and Japan for the treatment of CLL. As you probably know, the BTK pathway is very upstream from this inflammatory cascade. And actually, we believe turning off this main switch will downregulate the production of many cytokines and chemokines, not only IL-6, which everybody's focused on, but also IL-1, IL-7, and many others. We've had many encouraging early clinical results in patients treated in the US, and as a result, we've launched this randomized study called CALAVI in the US and a few countries in Europe. And finally, in the hope of protecting kidneys and heart, we are using our SGLT2 inhibitor, dapagliflozin, which has demonstrated good results in heart failure and kidney disease in both diabetic and non-diabetic patients. So we just launched a phase 3 randomized study in the US to explore the potential organ protection that this agent could offer COVID-19 patients. So this is really the extent of what we've done, and I have said it many times to our teams at AZ, they're really truly putting a heroic effort, maintaining, keeping the company going, but also investing a lot of time and effort in fighting COVID and coming up with potentially new solutions. So I find that the title of today's session is very appropriate, and I have no doubt that we will soon come out of the darkness, and I can see plenty of light already, not least with how we are united to respond, but also with the lifting of restrictions in Wuhan and many countries in Asia, but also progressively in Europe today. So with your collective efforts and your input and your great experience, I'm sure we can accelerate the fight against COVID. And again, today, I would like to thank you very much for your time, and I look forward to a very stimulating session. I will now hand over to Professor Zhong for the first of a series of updates that will help to set the scene for discussions. Professor Zhong, over to you.
Thank you, Dr. Sorio. And Professor Zhong, please, if you will share with us your latest scientific update on the COVID situation in China from a scientific perspective. Thank you very much.
Right. Thank you very much, Chris and Sorio. So it's my pleasure.
Hello, Professor Zhong? Hello? Hello? I think we seem to be having a little technical difficulty here with the web link again.
Professor Zhong, we can hear you now if you can speak.
Hello?
Hello, please continue.
Hello, can you hear me?
Yes, we will most likely turn off your video.
All right. Sorry about that. So, and okay, and just make 2 points because the time's limitation. So first of all, because I think the follow-up two, and from the States and UK, we talk about how they are going to deal with the coming COVID-19 infection. That's why I would like to mention again very briefly about the strategy of in controlling further spreading in China. So this is the picture coming from the UK, how control measures may reduce spread of virus in UK as we relate the new cases over time here. So no action, everybody knows, will be an outbreak when out of the control of the national health system capacity. So somebody else should take some control to reduce the spread. So they include self-isolating if ill, so social distancing for vulnerable, and whole household isolation if one member is ill. I suppose this kind of policy is not may not include the close contact, That's a big problem in China in facing. So one, the policies, one is suppression, another one just mitigation. I think suppression is take a very strong action towards the pandemic, but of course, that in the other way will make a great impact on the economy. So the other way is the mitigation, just make a delay of the outbreak. But because of the high reproductive ratio or not, that may not be work. So what China have been doing. So I think I'm not just very briefly to mention about the 4 measures. So knock down Wuhan, because at that time, so at the end of January, so basically only Wuhan had an outbreak, not other places. So, and then make it more transparent, real-time announcement of the number of diagnosed patients every day in each city. And then the most important, the so-called interagency mechanism. So the launch, the early self-protection and also early detection, early diagnosis going just to the large hospital rather than getting more final approval by the CDC and early isolation. That action is down to the community, and also PCR test checkup in all close contacts, including those without symptoms. So this is something happened at that day, on that day in Wuhan. So the point is very briefly saying, so the newly diagnosed cases increased since the 23rd of January, increased. So 2 weeks so it reaching the peak. So more than 3,000 per day, and then going down, and then after another 2 weeks going to the formal level, and this is the situation in China. So it only took 1 month. So this is the curve of that. So I think and the other some outside China. So this I think the majority of the the country, they have taken some action as early as February, but the majority of the countries take a little bit stronger action in the beginning of March. But I think it's not strong enough. So that's why after 1 month, the increasing rate is still going up. That's from Spain, Germany, and France, and
Professor Zhong, we seem to have lost your line again.
Hello, hi, Professor Zhong. Professor Zhong. Okay, unfortunately, we seem to have lost Professor Zhong's line. We might come back to him a little bit later. If, in the interest of time, we might move forward, and may I introduce Dr. Fernando J. Martinez, Chief of the Division of Pulmonary and Critical Care Medicine at Weill Cornell University of Medicine at New York City. Professor Martinez, please, if you could share with us the situation in the US with regards to prevention measures, current treatment protocols, and the key challenges that you're facing in managing severe COVID-19. Thank you.
Yes, can you hear me?
Yes, we can.
Okay, I'm going to leave my video off because it creates problems with the transmission. So thanks so much for allowing me to participate with such an august panel of individuals. And you provided a wonderful introduction regarding the global impact of this pandemic. Sadly, the U.S. has become the epicenter globally now, with 30% of the overall cases. And in New York City, we sadly as well tend to being the epicenter of the United States. So we have had quite a bit of experience over the last 5 to 6 weeks, which has proven to be quite a challenge. The characteristics of the population in the U.S., particularly in New York City, have been published in the last couple of days by our group in the New England Journal of Medicine. So you could look at that particular communication, Parag Goyal is the first author. The characteristics, as you can imagine, are very similar to the characteristics that have been reported from other groups, with a slightly higher incidence of gastrointestinal presenting side effects in the US and associated with worse outcome, and a much more significant role of obesity that has really become a very strong predictor of bad outcomes in the US. I suspect there's some important mechanism behind that, but I leave that to my translational scientists to aid in defining. The approach that has been taken at our institution to the management of a multifold increase in hospitalizations, thousands of hospitalizations, and critical care hospitalizations has been published in the Blue Journal in the last several days. So I would encourage you to look at the paper by the intensive care directors at my institution. Kelly Griffin is the first author because it provides very granular recommendations regarding how to consider surging an ICU plan in anticipation of the impact of a pandemic on critical care resources. It's a lovely piece of work that has quite a bit of very practical details. Again, it's on the Blue Journal website online, so you should take a peek at that. The approach to the management of individuals, particularly those with severe disease, since those are the ones that we tend to see in our pulmonary and critical care group, as all of you realize, is rapidly evolving. And even though there are recommended guidelines, including a practice guideline that our group is in the process of revising, all of these are based on relatively poor data and anecdotal experience. I've spent my life doing designing and conducting randomized trials, and so the database that is available is weak for making strong recommendations. The ventilatory strategy is one of those areas of controversy, and you've seen that playing out in the literature, even in the Blue Journal. In the last couple of weeks, there have been contrary recommendations. There is a series of 200 ventilated patients from our institution that is in review, which demonstrates that, by and large, the ARDS syndromic picture that we see with this particular virus, from the point of view of ventilatory mechanics, is actually remarkably similar to what has been previously published, with quite a bit of heterogeneity. And one of the major differences, I think, is the component of dead space, which does seem to be quite a bit higher, and it raises important biological mechanisms and alterations in the therapeutic strategy. I'll get to those in a second. So once that paper is published, you'll get a better sense, a much more comprehensive sense of the potential ventilatory approaches that are taken or should be considered in this particular disorder. The approach that's taken at our institution has been that following the ARDS-NET criteria that some of us published many years ago, which regarding low tidal volume ventilation in the majority of people, a fluid strategy that fits with the ARDS-NET strategy, with the understanding that in the first day or two, these patients generally have been febrile and have had quite a bit of insensible loss. And so their fluid status is a little bit more liberal early on, a little bit tighter later on, with an understanding that renal involvement is quite frequent, and that has to be kept in consideration as you're defining a fluid strategy. But generally, the approach that we've tried to follow has been that has been confirmed in prior randomized control data, with my experience being predominantly with the ARDS-NET. The pharmacological treatment of these patients remains completely conjecture. In fact, there is a lovely review in JAMA 2 days ago from a group at the University of Texas, which is titled Pharmacological Treatments for COVID-19. Their conclusion is, no proven effective therapy for this virus currently exists. And so I think that has been one of the major limitations that all of us have had. And Pascal, I appreciate your company getting involved in this component. And that level of heterogeneity in therapeutic approaches is reflected by a long meeting that we had yesterday at our institution, as we were trying to define the approach to steroid therapy in managing the cytokine storm that I'm sure all of you have seen at week 8 to 10, in day 8 to 10 in the syndrome of this particular infection. And in New York City, every single institution has a completely different steroid protocol. of when they use it, how they use it, what dose they use, what agent they use, and how long they use it. And so our conclusion was there was no conclusion. The approaches to dealing with in a much more targeted fashion to this cytokine storm that we see that has some features consistent with a macrophage activating syndrome have varied from IL-1 to IL-6 to GM-CSF. Pascal, you offered new potential options, again with an understanding that within New York City, every institution does something completely different in this regard. All of you have seen, and this has been reported in multiple groups, including some of the authors that are speaking today, a very strong hypercoagulable state in a series of patients, both clinically and in pathological samples from patients who have succumbed to this disease. And so there has been a tremendous interest also in systemizing, providing a cohesive approach to the management of that particular aspect of this disorder. Sadly, again, on polling every institution in New York City, there's a completely different approach that's taken to that as well. But it is clinically and syndromically a very important component of this disorder. And so my sense has been that COVID-19 is here to stay, guys. It is not going to go away. We need to develop a system to manage it, to mitigate it and suppress it, in whatever terminology you would like to use, but also to develop a series of cohesive approaches that allow us to target the heterogeneity of the presenting features of this disease, which likely reflect heterogeneity in biological mechanisms. And the optimal approach to achieving that is global collaboration in defining approaches. That includes all of you on this call, and an approach that is collaborative across institutions, federal, in our case, federal sponsor of studies, and Pascal, you and your colleagues from the point of view of industry all have to collaborate to be able to develop a series of evidence-based approaches to diagnosis of the disease, characterizing the clinical and biological heterogeneity of the disease, and allowing us, when we have this presentation next, to have a series of evidence-based recommendations that clearly can be applied broadly globally that will improve the outcome of this particular infection. Now, having been involved in the care of hundreds of these patients, it is an impressive sight to behold. I am old. I've been doing this a long time. I have never seen anything like this. And so I think it's a charge to all of you to collaborate and to define better sets of approaches to these patients, because sadly, I suspect that this particular coronavirus is here to stay, and we have to be able to develop better approaches to management. Thanks.
Thank you very much, Professor Martinez, for your insights and sharing your experience in New York. I mean, I certainly I think we all take on board your call for collaboration and a coordinated approach to this. In the interest of time, we're going to move on very quickly because we have a Q&A session at the end of this. I'd like to take this opportunity to come back to Professor Zhong Nanshan, who's online with us again from Guangzhou. So Professor Zhong, please, if you could continue the conversation from where you left off. I'm sorry about the signal.
Right, can you hear me?
Yes, we can.
All right. Let me skip. So maybe I'm wrong, but so maybe I'm wrong, but the curve or something like that. In the early beginning, I mean, Wuhan is lots of control in a very short time, and then when it is being obstructed, and then so for more than 50,000 medical staff going from different part of China, and then support Wuhan, and the situations quickly being controlled. I think at the moment in Europe as well and the United States, I think at the moment at this stage, I suppose if we loosen the role, I suppose so maybe we'll have a further curve, because the number is still increasing. So that's something worry me. So I hope in Europe we're going to the plateau and then going down in the next 1 or 2 weeks. And I don't know what will be happening in the USA. That's what I suppose. And okay, the next point I would like to mention about the asymptomatic, so COVID-19 infection, whether they, how many patients is that, and then whether they being discussed in China. So that first of all, I would like to mention the so-called, what does it call, definition of asymptomatics with COVID-19 infection. Of course, the first is a pre-symptomatic patient. Of course, they are in the incubation period. So the second may be asymptomatic with COVID-19 infected. That, in other words, PCR showing positive, but just asymptomatic. And the third may be patient with very mild symptoms being neglected by the patient themselves. That's a part. And the fourth, no symptoms at all. When you are following up,
Hello, Professor Zhong.
positive. Sorry?
Can
you hear me?
Yes, we can.
Okay. So this patient should be diagnosed as having COVID-19 infection. We have seen very few patients with serum with a long time of positive PCR, and the serum antibody always so negative, both IgM and IgG. Maybe we will call this patient with the so-called virus carrier or something like that. So remains to be solved. So that the transmission is, as you know, so the, okay. As you know, the pre-symptomatic, of course, is transmission and infective, and then symptomatic infective. So how about this kind, asymptomatic patient? So transmission of virus from a person who does not develop symptoms, that remain to be discussed. So as you know, we have some data showing of the patients. So from our data, when 1,099 patients beginning, the median incubation time is four days. We have found 13 cases with approximately 1% with the as a so-called asymptomatic, pre-symptomatic, and the next one is just in preprint. So they were 7.45% with pre-symptomatic, and another paper showing 12.6 that of cases indicate pre-symptomatic transmission. That varies a lot, and that's from China CDC in February. They had make a survey and see, so within 72,000 report cases, and have found 889%. That's only, let's see, that's only, let's see, 1.2% with this kind of similar to our data. So in some very special groups, like in New York City, so 215 pregnancy women, they have found 33 PCR positive among them. So 88% is asymptomatic. PCR positive. So that's vary a lot. So that's significance of the asymptomatic carrier. So whether what kind of role they are playing in the transmission. So we need to have a nationwide survey. How many asymptomatic patients, the so-called patient with COVID-19 infection? That's one study just coming out. So the last week, that's a PCR test have been carried out in 275 workers, civil servants in Wuhan, and among them, so 182 so positive. Like 6.6 per 10,000, 10,000, right? No, 100,000. And that's data. We just want to see the so-called background of the serum positive rate. This is in Wuhan area, the outside Hubei area. You can the CRF, the case fatality rate is pretty high in Hubei area and pretty low in other area. And then we have made a survey in about 300 patients inside. That's inside hospital, not the whole survey inside hospital. And then and this in Wuhan, one hospital. That's in our hospital, 2,000. Imagine at this time. So that's CFR, and also the IgM, IgG positive. So it shows 2.5% in Wuhan area and 0.9% in other area. In other words, so the so-called herd immunity is far from reaching that. So that's whether this kind of asymptomatic patient will be capable of transmission. I suppose this is the first paper from Chris and Professor Yun, and the 6 family members, Australia, Chinese, had been 5 of them been in Wuhan and transmit 1 of them, so who had not been in Wuhan, and just before the symptom occur. That's I'm not going to talk too much about that. And another one example is asymptomatic carrier transmission. So that's a presumed asymptomatic carrier transmission. So again, a familial cluster of 5 patients with COVID-19 pneumonia in Anyang, China, had the contact before their symptom onset with an asymptomatic family member here. Also show asymptomatic patient will have some infectivity over to the other person. So this is another case showing a gentleman who attend a meeting in Germany with some partners, and then when he flew back and developed symptoms and eventually diagnosed as having COVID-19 infection, and the others also, so we contact them without symptoms. So, however, there are some study is not showing this case. Study claim that new coronavirus can be transmitted by the asymptomatic by people without symptoms was fraud. Why? Because in this study showing that according to the people familiar with the cold, and then she felt tired and suffered from muscle pain and took paracetamol and fever lowering medication. In other words, this patient actually is not asymptomatic, but very mildly symptomatic transmission. So from the CDC, China CDC had now announced, so we should endorse close surveillance and observation of the close contacts since 2 to 4 days before illness onset. And during this symptom onset, 1 to 2 days before and after symptom onset. That's very important. So another study just showing that support these. This is actually some patient who had already had symptoms, but the first 3 to 5 days, their virus load in the nasal and then throat and the sore is pretty high. So after 5 days and going down, and then so very weak. In this way, in other words, so it really means so will be will have some infectivity of the asymptomatic person. But as I know, so the big proportion of the work is in preprint status, had not been clarified by peer review. So we need a big number of screening and longitudinal study. And can the asymptomatic infect person spread the virus, and how efficient? And so we need to have a further study, big data study to prove that. So actually we should identify asymptomatic infection, isolation for 2 weeks. So that's what I I have mentioned. I should thank of all my colleagues and from Zhongshan University, from my institute, as well as Zhong from AstraZeneca. Thank you very much.
Thank you very much, Professor Zhong. Before we move on to Professor Mike Grocott, I just want to pick up on one point. I think Dr. Martinez, while you were just sorting out the connection there, mentioned a new normal, that he didn't think this was going to go away. And I think over the last weeks, it's come to the attention of all of us that asymptomatic transmission, as you mentioned, Professor Zhong, is a key to this. So, and I suppose this is an advocate for early and widespread testing. We are very concerned about the 1.2% that you highlight in your data set. Because the concern there is with a denominator of 2.2 million infected cases globally, you're talking potentially about anywhere above 200,000 asymptomatic carriers or transmitters who will be able to spread the virus in a new transmission dynamic, which Dr. Martinez has alluded to. I will refer everyone to a paper that was published in Science just this week by Stephen Kissler's group and Mark Lipsitch. The paper is titled Projecting the Transmission Dynamics of SARS-CoV through the Post-Pandemic Period. And they're talking there, I think, very much about the sort of stochastic or resonance effect of repeated cycles of infection throughout the wider sort of community and population. I think this is just something to bear in mind as we move towards the Q&A session at the end. I won't hold the proceedings up, so I'm going to invite Professor Mike Grocott next to share with us his experience on intensive care and learning to do it in the UK. So Professor Grocott, please.
Thank you, Christopher, for the opportunity to contribute to this seminar, and particularly to AstraZeneca and Pascal for supporting this sharing of learning. I'm going to change tack a little bit and talk principally about intensive care, critical care, and COVID-19, and in particular in relation to our experience in the United Kingdom. My slides seem to have frozen up, but I'll tell you what, I know. Okay, so if I start with the challenge, which is this novel disease with extraordinary epidemiology that threatens to overwhelm, and in some cases does overwhelm, our health systems, the potential for novel phenotypes, and I'll come back to that later, particularly in relation to severe respiratory illness, and the interaction with politics, policy, and people that we often don't have in medicine in terms of the necessity for dramatic social change. And I'll also talk a little bit about our response, the surge in activity in all aspects of how we run health systems as a reply to COVID-19, and some of the differences in clinical care and decision making. And I will focus principally on the epidemiology in the UK and our clinical experience, and a couple of personal reflections at the end of the presentation. So if I start with the epidemiology, you will probably be aware that the UK is 6th now in terms of the total number of cases, but I think in comparison to many countries, we have done relatively few tests, and sadly we are 5th in terms of the total number of deaths, with approaching 15,000 deaths in the United Kingdom now. We commenced lockdown and social isolation on the 23rd of March, and you can see in the upper black and white graphic the continuing increase in the number of daily cases for at least a week or 10 days after that before they start to plateau, and then tailing that in the lower black and white graphic, the number of deaths increasing until a plateau probably 2.5 weeks later. And in the coloured graphic, you can see our total NHS bed usage, and reassuringly that has started to plateau, and indeed the most recent data suggests that started to decrease. If we look at our intensive care bed usage in terms of, you can see on our vertical axis there, up to 4,000 beds, that is also clearly starting to plateau. And in some centres, they're starting to see a modest decrease in intensive care bed usage, which is overwhelmingly by COVID-19 patients at the moment. Like many countries, we have a high degree of diversity in terms of the experience of people around the United Kingdom, with hotspots in London and some of the other major metropolitan centres. And you can see the 3 local critical care networks that have been most severely affected are all in London. London led us temporarily into this epidemic, and it may be that some of the areas outside of London will be fortunate because social isolation was effectively earlier in the growth curve of the spread of this virus. These are data from our Intensive Care National Audit and Research Centre showing, not surprisingly, that overwhelmingly the indication for admission to intensive care was respiratory support, of which about 2/3 to 3/4 was invasive ventilation, the remainder being non-invasive ventilation, CPAP and BiPAP. Many patients requiring either simple or advanced cardiovascular support, and a significant incidence, on average about 20%, but with some centres seeing up to 30% or more of renal impairment. And in terms of survival, although we have relatively few completed episodes, you can see at the moment that our overall survival is about 50% of those episodes that are completed. And if you were not ventilated within the first 24 hours, your outcome was substantially better than if you were. If I focus on our clinical guidelines now, we've shared a lot of information about how to deal with the surge in demand related to COVID-19. And that's involved, as it has in many places around the world, expanding the locations in which we deliver critical care, both within hospitals, onto other critical care units, onto normal wards, and indeed into new facilities, the so-called Nightingale hospitals, which are converted non-hospital facilities with a very large capacity for looking after critically ill patients. We've had people coming into critical care to support the specialists, many anesthesiologists, but also other specialists, including surgeons and physicians. We've procured a huge amount of equipment and consumables, as everyone else has. And we've had some very interesting discussions around decisions, and I'll come back to that at the conclusion of this presentation. And I think the 3 key lessons have been, first of all, the importance of communication, clarity of communication, and kindness, compassion in communication when we have so many different people coming into critical care, some of them who haven't been exposed to it before or not for a long period of time. The importance of mutual aid, which is how we describe the sharing of resources between different parts of a hospital and between different hospitals, should an individual hospital be overwhelmed in terms of critical care demand, and indeed around the country, including the Nightingale facilities. And increasingly our recognition that this is going to be a very long and drawn out experience. It's a marathon, not a sprint, and we need to be careful in marshalling our resources over a long period of time. As has been talked about already, there are no known effective treatments or prophylactic measures for COVID-19 or the SARS-CoV-2 virus. There are several candidates, and we are investing a huge amount of effort into nationally approved platform trials evaluating different aspects of therapy, including antibiotic therapy, direct antiviral medication, steroid use, and other immune modulators. And we're achieving a high degree of recruitment to these, REMAP-CAP being the international critical care platform study that most patients are going into. We are struggling a little bit with antibiotic therapy. I think we all believe we probably shouldn't be giving antibiotics when patients first come to us. Co-infection rates with bacteria are relatively low, but it can be very difficult in a febrile patient who with a pneumonic process not to administer antibiotics. We're increasingly leaning on procalcitonin, and we're very conscious of the importance of antimicrobial stewardship, both at a population level, but also for individual patients. The patients who are getting a lot of antibiotics earlier, also we're starting to see late fungal infections. We're not recommending routine steroid therapy, but clearly replacement should be continued, and anything that would normally require treatment with steroids should be treated in that way. In terms of the management of respiratory failure, I think we've got competing challenges. There's the risk of disseminating infection through so-called aerosol generating procedures. There are potential resource constraints. Several of our hospitals have exceeded their oxygen supply due to use of invasive ventilation and high flow CPAP devices, along with lots of ward oxygen. And there's a lot of focus on how to manage that, and the question of how to manage different clinical phenotypes. But as a clinical reflection, I'm a research doctor, but I have to say the most important thing I think for us has been the reliable and effective delivery of normal care that we're used to doing, and including normal care for the respiratory distress syndrome a la ARDSNet, as has been discussed already. There is some move to lower oxygen therapy targets. In general, we're aiming for about 92 to 96%, but in carefully monitored environments, national guidelines now accept 90 to 93%, and there are undoubtedly individual clinicians who are aiming for targets lower than that with uncertain efficacy. We are in general avoiding high flow nasal oxygen because of both the risks of aerosol generation and infection spread and the use of oxygen, a potentially scarce resource. But there's a substantial amount of non-invasive ventilation and CPAP going on, and some patients are undoubtedly avoiding invasive ventilation through that route. And obviously many patients are invasively ventilated, but there's a spectrum of approaches to the timing and thresholds for mechanical ventilation. There's a huge amount of prone positioning going on, including self-proning prior to intubation in patients on NIV, some use of pulmonary vasodilators, and increasingly, I think, tracheostomy as a means of supporting patients who have a high incidence of failed extubation and often a long period, lots of sedative drugs, and it's a means of managing limited drug supplies. I've touched on corticosteroids and the incidence of fungal infections already. We do recognize, as many others have, these potential two different phenotypes, but I think many people's belief is that the low elastance, high compliance, non-recruitable pneumonitis phenotype probably progresses towards the ARDS phenotype. A few patients are lucky enough just to get the pneumonitis phenotype, but most in our experience progress through the ARDS phenotype. And the two striking non-respiratory organ failures we've had have been the significant incidence of renal failure, and others have touched on the thromboembolic components, and we've definitely had a shift towards more generous thromboembolic prophylaxis and earlier implementation of anticoagulation. So to conclude, in terms of clinical decision making, we are definitely not business as usual, but we are also definitely not resource limited. The total number of patients is well within our current capacity, and although there's local resource stress, we are decision making as normal, both for COVID-19, and we're trying to do the same for non-COVID-19 patients. We're increasingly aware this is going to be a long journey, and we may have parallel COVID and non-COVID health systems looking months or even years ahead. And once again, I emphasize the importance of clear communication, lots of different people coming together to treat for these patients who may not have worked together so much before, and compassion and kindness dealing with our colleagues. It's never easy under such challenging circumstances. Thank you very much for listening.
Thank you very much, Professor Grocott, for sharing with us your excellent communication, clarity, and compassion on this subject. I particularly like your sort of framework for looking forward and managing this in both COVID and NOVID form. I just one of the key points I picked up there is the different phenotypes and the progression from pneumonitis to ARDS, and I think that's something that we can perhaps start to focus on. There has been a lot of discussion, of course, about the nature of inflammation around the pneumonitis and the early presentation, perhaps in the slightly more mild or moderate forms, which then move on to sort of ARDS and fulminant respiratory failure. We do have two more presentations before the Q&A session, so I'll move on now to introduce Professor Jieming of Ruijin University, Shanghai Jiao Tong University School of Medicine, and the president of the Chinese Thoracic Society. So Professor Chu, if you would like to share with us, please, your suppression strategy for citywide defense in Shanghai and China. Thank you.
Hello, distinguished monitor, chairman, and the colleagues. Today, I think it's a very honor to have the opportunity to exchange the experience from the Shanghai, China, for against of the COVID-19. Since the July 23rd, 2020, Shanghai launched level 1 public health incident alert. I think this is the top level of the China's public health alert system. So according to this public policy, Shanghai established a very integrated strategy. You can see we combined the integrated government, hospital for against COVID-19. For example, you can see the government defense for COVID-19 in Shanghai. We focus on the 5 aspects. Just so you can see the strict management of the access to Shanghai, just for airport and the railway station, and the temperature monitoring was carried out for all kinds of the access into Shanghai. So everyone with fever or symptoms, there will be sent to the isolation site promptly. Another very important thing by the government, we should do the surveillance of the personnel. You can see the people should advancedly online just get into, they want to get into Shanghai. Every people should submit their travel history and health information online. The third is an important issue, just we established the code electronic data system. We called QR color. You can see the different colors, green, yellow, or red. Just if this data system code electronically sued the green, that means the person has no abnormality, has been cleared of the medical management measures. If this shows the yellow, those should be to the Shanghai, I think it's from the key epidemic areas, so just less than 2 weeks. If it's a red color, then the people should be quarantined. So people who have not been freed of the medical management measure and have been diagnosed and are not being discharged. So whose infection has not been ruled out. So there are 3 different colors. It is a very unrestricted gathering for people. It's a very important approach. You can see this is Disneyland, and this is a restaurant, subway, and the viaduct of the Shanghai market. There was no people gathering. So I think it's a very important approach for stop the spread of the COVID-19. The other very important issue just for the government for performing disclosure of the daily report. It can reduce the panic and stabilize social mood through daily report. I think it's a very important function for this disclosure. Another very important function for disclosure of a daily report, this can do some very important things. For example, they can disclose the information of the COVID-19 patients, of the cases, and the public health education, and the refutation of the rumor, etc. Another very important policy for Shanghai, just for against COVID-19, this is, I think, for the hospital defense. You can see these 3 aspects, including the patient management and the human sources management, and it's a very effective strategy for screening strategy. You can see fever clinicals set up and isolated ward and disconnected hospital. So after we have established of this very effective strategy for hospital, you can see the achievement of COVID-19 defense in Shanghai. You can see Shanghai exacerbated very high efficiency epidemic controlling ability and stopped the exponential growth. And the total confirmed cases, just only 628 cases by April 15th. Among them, just nearly 290 cases imported from abroad. There is some pictures shows the committee management. You can see every resident, they want to into the committee to be finish screen for temperature and the information register. And also you can see the committee management, the person to do some checking door to door. And another very important thing is propaganda for committee in the among the areas. And another very important for the committee activity, just I think it's the public consensus. So this is very important for the citizen, for the public civilians. They should do the wearing mask, hand hygiene, and reducing contact with others, and also do some self-isolating and self-monitoring. You can see this picture. This is social distance, like 2 meters apart. And the control strategy for the important cases as another very important for the government and the committee controlling policy for the important cases. The last things I think is especially in the Europe and North America, there will be great epidemic period. There will be a good experience for Hongkong Theater Hospital establishment. There is a large scale temporary hospital and rapidly built by the converting existing public venues such as stadiums, exacerbation centers, etc. So this Hongkong Theater Hospital served to isolate the patients with mild to moderate COVID-19 from the family and the community. There's several functions. Function 1, you can it be as isolation, and a second function just the toilet. And as a third function, you just I think it's separated the other kind of the disease co-infections. So this is very important. So after this Hongkong Theater Hospital establishment, you can see the result. This map shows the result, the progressing of the bed capacity and occupies of the Hongkong Theater Hospital over time. You can see only described evidence the Hongkong Theater Hospital will as a major reason for successful COVID-19 control in China, because you can see much more beds waiting for patients of the COVID-19. So this is for my talk's conclusion. Strategy for COVID-19 defense in Shanghai of the China, depending on the efforts of the government, hospitals, and the committee as an integrating body. So Shanghai exhibited high efficiency epidemics control ability. Thank you.
Thank you very much, Professor Chu. Regardless of which country we're in or which population we're responsible for looking after from a public health perspective, I think we can all agree that there's a lot of concordance in the way we have to approach this pandemic now. And the individual measures taken by governments, hospitals, and the community are becoming much more consistent in recent weeks. I think the difficulty is sometimes when things are far away, it can become less clear, or our visual acuity becomes a little bit less sharp or astute. But certainly while you were in Shanghai, I was in Hong Kong and in Shenzhen, and we took very much in other cities across China the same measures as you did in Shanghai. So I think, you know, there is a lot of consistency, certainly in regional parts of the world. I'd like to move on now to invite Dr. Zhang Wenhong to share with us an update on his strategies and in preventing mild COVID-19 to severe conversion. So the transition from mild to moderate to severe that we've seen in so many of our patients. Professor Zhang, please.
Okay, dear colleagues and dear Chairman, okay, yeah. Can you hear me? Hui, Dr. Hui, can you hear me?
Yes, we can. Thank you.
Yes, okay, good. Okay. I'm very glad that Shu shares some strategy for preventing the mild and the COVID to severe conversion. I think recently it's very important for us for stop the progression of the disease, because globally there are so many patients. If we want to decrease the mortality, I think it's very important for us to keep the number of the critical care patients not so many. So recently we observed that in some countries the mortality is much higher, but the other countries just like Germany and just like China and also China, Hong Kong, I think we found that mortality not so high. I think the majorly, I think the cause for this phenomenon is that we always keep the critical ill patient not so many. So Professor Chu also mentioned that because we controlled the numbers of the patients in Shanghai, so they are not keep our all the cases number not so many and keeps a very low level. However, now recently we noticed that at the first wave of Shanghai, all the patients from China, Wuhan epicenter, but now today we almost cured all the patients from Wuhan. But today we just treated the cases from other countries. So that means all the cases in Shanghai recently are imported cases. So we just get some experience from our first wave of the disease. We just think that it's more important for us in recently that we just want to stop the progression of the disease. According to our observations from our first wave, the treatment, we found that according to the timeline of the COVID cases after onset of the illness, we will found that almost we found that a median time for the patient progression for the mild or moderate to severe is around 7 days to 10 days after the onset of symptoms. So therefore, we want to stop the progression at that very early stage is very important for us. But what's the mechanism for the progression of the disease? According to some basic research and also from autopsy, we can find some inflammatory mechanisms associated with the progression of disease. This study is from China. I think it's the first data from the autopsy. We can find that in the critical ill patients, in their patients with the ARDS, we found there's a higher lung membrane inflammation, interstitial mononuclear inflammatory infiltrations, and also we can see that the thrombosis in pulmonary arteries also is very significantly. So therefore, I think the cytokine storm and the inflammatory mechanism and the coagulation mechanism is very important. Today, we know that in the COVID disease, immune defense-based protective phase, the adaptive immune, most in the very early stage, it will be suppressed by the virus. However, on the other side, as a balance of the mechanism of immune function, we will see that the inflammation-driven damage phase, we can call it that, the pro-inflammatory cytokines, and also the innate immune will be strengthened by our host. So therefore, I think at this stage, we should suppress some kind for the innate immune, also the inflammatory cytokine. But what kind of the cytokines?
Professor Zhang, please, if I can interrupt you, your slides aren't rolling.
Okay. Can you see that? Okay. So there's lots of predictors for progressions of the D dimer and lymphocyte and the ferritin, LDH, and the IL-6. So D dimer, I think, also is very important. The IL-6 stand for the inflammatory cytokines level. So these two kinds indicate, I think, is the most important. Therefore, there's some strategy we can take. So first of all, we will give all the patients anticoagulant in COVID according to the level of the D dimer. So we will control the coagulation level to the very satisfactory range. Is very important for us to keep the progression of the disease. Meanwhile, some patients we will give the biological antagonists, just like the IL-6 antagonists. And of course, the corticosteroids also will be used in some patients at a very short window, just a very narrow window in the patients. If the disease progresses very fastly with in the CT scan, as we can see the lesion expansion very fastly. Also, the LDH increased. We will give the short duration and low to moderate dosage of the steroid for the patients. So these kinds of the intervention, I think it can give us some help for keep the progression of the disease. So I think in the future, to save the critical ill patients will not decrease the mortality very fastly. However, control the progression of the disease is more important. So this is our experience in recently. I think it maybe will help us to decrease the mortality in the future. Thank you.
Thank you very much, Professor Zhang. Unfortunately, there seems to be a technical error. We weren't able to see all of your slides, but what I might offer is that we can recap or send those out on request at a later point if necessary. In the interest of time, we're going to move forward with Dr. Gary Wong now at Chinese University, Hong Kong, who's going to share with us his experience of managing COVID-19 infection in children in Hong Kong, China. Thank you. Dr. Gary Wong, please, can you unmute your microphone? Dr.
All
Wong,
right.
we can't
How's
hear.
that?
Yeah, thank you.
Yeah, can you hear me?
That's much
Yeah.
better. Thank
All
you.
right. Let me just share the screen. All right. I'll keep my video off. It's probably the system is a little bit more stable. So thank you for the opportunity. I think overall, if you look at the pediatricians in terms of the work in the hospital, they have a slightly less difficult because first of all, the number of children affected is a very small fraction of the total number of patients. And if you look at the data in China, it's something like 2% under 20 years of age. So in order to get a good experience of what exactly is the disease clinical manifestation and how to manage them properly, we gathered a group and initially we analyzed the initial data set coming out from Wuhan Children's Hospital, which is the only vaccinated hospital looking after children under 16 years of age with this infection. And prior to our analysis, there have been a few reports with seems to be, first of all, the disease is uncommon in children, and second, even if they get it, they are not very sick. And But when we look at this initial cohort from Wuhan Children's Hospital, close to 100, a little over 170 of them. And one thing very clear early on in the outbreak is children seems to get the disease from infected adult within the same household. But mind you, in this initial cohort, though, there were 4 children actually within the same family, that the children developed the symptoms first before an adult within the same family developed the symptoms. And of course, you know, they can be exposed to the same source such that the incubation period may be shorter for the children than the adults, but we really cannot rule out the possibility that actually the children were infected first and then spread the infection to the adults. And with that initial impression that it tends to run in the family, a later part of the outbreak, we start screening all the children, regardless of whether they have symptoms or not. As long as within the same household there is an infected adult, we screen them. And that probably explains some of the results that when we analyze this initial data set. As you can see here, the median age is around 6.7. And one thing I would like to point out, actually, the children or infants under 1 year of age tend to be overrepresented in the pediatric age group. As with many other respiratory infections in children, you see a slight male predominance. And as you can see here with the age breakdown, you see, children are susceptible to the infection regardless of the age. And in fact, as I said earlier, almost 20% of this cohort are under 1 year of age, and subsequently this data has been replicated in the US CDC data. And now one thing very clear in children is the symptoms are rather atypical. And in fact, only about 40% of them presented with fever at any time during the illness. And many of them, they may have a little bit of cough, very mild. And now one thing I would like to point out in children, actually, the GI symptoms actually is a little bit more common than in the adult population. And very few of them actually are sick. When one look at those with really require some oxygen therapy, invasive or non-invasive ventilation, only 4 out of the 171 patients actually required such treatment. So in the end, in this cohort, 3 of them required invasive mechanical ventilation. I like to point out, because the earlier discussion about the severe cases in adults, that they tend to have a concomitant renal problem. Among these 3 children who required mechanical ventilation, 2 of them actually required renal dialysis, and 1 of them died. And the laboratory features is very similar to the adults, but in a milder form. Among this cohort, only 6 of them had lymphopenia. And when one analyzed those with the symptomatic disease, now Professor Zhong earlier pointed out a very important aspect is, now in this cohort, 16% of them are asymptomatic. They have no symptoms whatsoever. And would like to also point it out, among these 107 children with pneumonia, actually 12 of them were picked up by radiological investigation. They had no symptoms either. So in fact, if you add those 2 groups up, actually around 25% of the children, 20% of the children actually are asymptomatic. And that's, as we can discuss later, makes a very important role in how we look after that group of children. And among those with symptoms, by and large, they recover rather uneventfully within very short duration of period. The majority of them, they will get better within a week. And for those with fever, which is 40% of them, they have a fever of a few days. And then from the onset of symptoms till they're PCR negative from their respiratory sample, it took around 2 weeks. And a few of them continue to excrete, continue to be detectable in terms of PCR in their stool samples. The CT abnormalities are very similar into what's been described in the adult population. As you see here, actually, this one is one of the more severe cases, and this is the 14-month-old who required invasive ventilation and dialysis, and again the ground glass abnormality again is the most common finding in the CT scans. Now there was another report. With more or less the initial numbers around Wuhan and the Hubei region with 731 confirmed case. As you can see here, also replicate our findings that, those under 1 year of age tends to be overrepresented. And I would also stress they tend to be symptomatic, although the symptoms are rather mild, a little bit of fever, cough, lethargy, decrease in appetite. And the severe case, now in China, there are total around 1,600 children under 20 years of age infected with the virus, and there has been 2 deaths. One had underlying leukemia. The other one in our cohort, actually, that child primarily presented with GI symptoms. In fact, it was intussusception. And the child had a very stormy course. In fact, the respiratory symptom came a little bit late, and then we investigated the child and found to have nasopharyngeal aspirate to be PCR positive for the virus. And she went down a very stormy course and then developed renal failure and then DIC, and after about 5 weeks died from the condition. And am I aware of another case in Middlesex Hospital in London, also an infant presented with intussusception with very mild respiratory symptoms. So I think the important point here would be for the children, a large fraction of them are asymptomatic. We really need to figure out their role in terms of propagating the infection within the community. And when one look at the early CDC data from the US, there are close to 2,600 cases, very similar. In their series, around 2% are children, and within their data set, 3 pediatric deaths, and they're still investigating. And in this report, they really do not have a lot of clinical details about their patients. And similar to our cohort, 2% of them required admission to the ICU, and by and large, they have underlying comorbid conditions. And also in their data set, again, they found an overrepresentation of infants in the pediatric age group. And as far as infection in pregnant women, as well as the neonates are concerned, it seems there is, now this is one of the largest study with 33 pregnant ladies infected in late pregnancy. And first of all, the ladies are not very sick, and only 3 out of the 33 mother-infant pair got infected, and 2 of them were terms and 1 of them preterm. And the preterm, the degree of illness is similar, actually, probably explained by the prematurity rather than infection. By and large, infants, when they got infected, they're not sick and they get well rather quickly. And of course, throughout different parts of the world, there are reports of children who died from the infection, and apparently these infants, children, and adolescents are otherwise healthy. So fatalities in otherwise healthy children are rare, but they do occur. So by and large, for infected children, they run a very mild course. And I think the most important point about this group of figure out their infective potential, their role in spreading the infection in the community. And of course, we need to watch out for children with comorbid conditions, and those infants are at risk for more severe disease. And they tend to present more atypical with GI symptoms. So clear understanding of the immune response really between the children and adult probably will give us a little bit of insights in the development of effective treatment and how to control the cytokine storm. And thank you.
Thank you very much, Professor Gary Wong. Gary, I think it's very interesting that you highlight these asymptomatic or minimally symptomatic children,
Right.
as this reflects our experience with the adult population, and I think it echoes very much what Professor Zhong mentioned earlier about the non-symptomatic transmitters within the community and what we can really do to screen them, either by testing or radiologically, perhaps more for the adults, but certainly over time to capture the chain of transmission and a better picture. I'm going to share with you just a few more slides before we move to the questions section. I am very aware that we're running over time, so I'm sorry about that. Let me see, or if someone can pull up my slides on the control center. I'm having, let me just see, sorry about this. I think sharing content from the I can't do this from screen. Okay, I'll do this from my screen.
Yeah, Professor Hugh, we will share your slides on the front end. If you want
Thank you. So just to really recap, because we were discussing this before last time at the end of March, and looking at the host immune responses and lung damage induced by severe COVID-19 infection. So the first slide shows you the CT scans that we're very familiar with and the progression from mild to moderate to severe. And we can stage this roughly into 3 stages now, with the asymptomatic incubation period, moving on to the non-severe symptomatic patients, and then those who develop a high viral load and a cytokine storm with acute lung injury and end organ failure on intensive care. Moving forward to the next slide, the SARS-CoV virus really does divide very nicely into early and late stage or severe stage inflammatory responses, and this was shared with Professor Helen Lackman at the UCL Institute for Immunology. We do know that lung inflammation remains the primary cause of life-threatening respiratory sort of endpoints in the ITU or ICU stage, and that once this lung damage occurs, efforts should be made to suppress the inflammation, but corticosteroids are obviously a very blunt instrument. And as Dr. Martinez has said in New York, there isn't a congruous application of steroids that we can apply coherently in terms of different management strategies and individualized it from both parts of the innate and adaptive immunity. And we can look at this, we can study this from the systemic autoinflammatory diseases, mutations that affect the innate immune response, and the class 2 HLA, the non-class 2 HLA associations, gender predisposition, autoantibodies, and antigen-specific T cells, etc. These are the so-called experiments in nature. But moving forward, we've been talking a lot here about the cytokine storm in London and the life-threatening and excessive inflammation that is driven by these cytokines. There are existing scores in rheumatology, such as the H score, which was published in Rheumatology in 2014, which looks at different metrics that we can measure, but there are still too many confusing terms. I think that the discussion comes back to the many potential target agents, and we're still, many of us, dwelling on the application or the potential for blockading targets such as IL-1, IL-1 receptor, IL-6, interferon gamma, and so on and so forth, Janus kinase inhibitor, etc. But the problem is that we've not, as has been said so far, we haven't found a sort of magic combination or a way of applying these levers and brakes on the inflammatory response in a cogent way, and I wonder whether or not it's not just the method or the drug, but whether we can apply it in series or in parallel to apply sort of stops to individual parts of the pathway, and so there's a great need, as has been mentioned, for many more clinical trials. In terms of IL-1, we said last time that there have been sort of ad hoc clinical trials in anakinra, and the use of it appears to be safe. But again, these are in the range of n = 3 at our own institutions here in London at the moment. There is a clinical trial that's due to start at the end of the month, and I think a lot of the question will be looking at sort of the stage at which this is most applicable, whether it's early application of the IL-1 target inhibitor or later on, and I think this is something that's going to be something that we have to look at going forward. If we can move to the sort of next slides, please, just going forward. You can go through to I think it's the 10th slide now. The summary is that there's really too little data on any of this for anything other than speculation at the moment, but we do reiterate that IL-6 is not the only target potential. There are others. Again, what we have to consider is the safety profile in all of this. There are anecdotal sort of stories of in 1 or 2 cases where this appears to have been workable. But again, you know, I think the outstanding issue is going to be on patient selection, timing and dosage and interaction of different agents, as has been said before. So with that, I'm just going to tie up that conversation so that we can move and enjoy 20 minutes or so for the question and answer section. I'm going to invite all the panelists together to answer these in turn, and I'm going to try and curate some of the questions that we have. We have collected a bank of 60 questions here from all countries around the world, and I'd like to just start with Professor Zhong, please, first. If he might share with us some of his thoughts on what the most important strategies are to improving the outcomes in severe COVID-19. What do you think on the basis of what's been discussed so far today? And I apologize if the sequence has been a little bit sort of out of order, but what do you think, Professor Zhong, the most important strategies are for improving outcomes, particularly with the mortality that we see at the moment?
Well, I suppose 2 points. First of all, I think that Professor Zhang, although I haven't looked at your slides very clearly, so because it doesn't work, but I think it's early detection is really important. I think if they can find out the patients earlier, so we can the patient receives some medical care whatsoever. So care. So the patient will be, I mean, less patient will be getting to the severe situation. And the second point may be important is to prevent those patients from developing critical ill situation. Those can reduce the mortality. So our actions, one of our measure is to give this patient with hydrogen plus oxygen mixed inhalation, gas inhalation. Because as far as when I was a student, so 60 years ago, so we have heard some treatment of inhalation with helium plus oxygen. That means that to decrease the density of the inhalation. But actually, helium, the molecular weight is much higher than the hydrogen. So hydrogen oxygen mixed inhalation is much better. So in those, because we are now at the moment for summary. So and thus we have found a lot of patients when they inhale hydrogen and oxygen inhalation will decrease the extent of dyspnea, which may in turn prevent them from becoming a severe situation. I think that's too maybe important.
Well, thank you very much, Professor Zhong. I'd like to just extend one more point on that. With the number that you've seen of non-symptomatic transmitters or minimally symptomatic, and we see this in many populations, they may account for the mild to moderate cases that cover over 80% of COVID infections. Do you think we've come to the point now where we are looking at screening entire populations with testing to confirm or refute their COVID status?
Yeah, I suppose yes. So I think I don't know whether I can catch your question or not. But anyway, we are now doing a survey, doing both from both sides. So RT-PCR and so serum antibodies. So I think we have if we have some background data, will be much easier for our policymakers to work out some other policy and how we are going to go to do next. Because as you know, although in the first phase in China seems to be quite successful, but actually we are aware we are facing the more dangerous situation in the second step, because the majority of the Chinese people are with no immuno response to COVID-19. So that's the point in China. As I mentioned before, so the background of antibodies, the number, the percentage is pretty low in Chinese.
It does seem to be the case that the presence of antibodies or sort of infection doesn't necessarily confer clinical immunity on the population. So there was previously a brief discussion about herd immunity, but I think we've moved past that. And I think I would reflect on very much on what you said about how we might sort of generate some data quickly to compare the sort of respective strategies between pan-population testing and subset population testing, so selective testing, because I think, as you say, many policymakers do require some of this data to help guide the way we approach this across different countries. Thank you very much. I'm going to move on now to, thank you, Professor Zhong. I'm going to move on now to Dr. Martinez in New York. And I just wonder, this is a question from the UK actually, where have you seen similar sort of, with the data that's coming out now with the predominance of significantly more male deaths in the UK ITU system? Are you reflecting this in North America as well? And what are your thoughts on the bias between male and female infection that we are seeing in the data that's coming out now? More and more, we think this is to do with perhaps potentially the ACE2 pathway of entry for the virus, which is X-linked, of course. And I've had very interesting discussions here about skewed lionization, where selective copies are taken up in females, which may confer some protection. What are your thoughts on the male-female split?
Well, I think that your colleagues in the UK have made a very similar observation to what we've made here and what we've recently published on our evolving data. There is an imbalance between the genders with respect to certainly hospitalized patients. The imbalance is a little bit less dramatic with regards to overall infections. And Professor Zhang's comments regarding asymptomatic infection, who knows what that's going to reflect. I totally agree with his thoughts that this is going to require widespread either population-based or population sampling-based testing, both serologically and with RT-PCR, to be able to get a sense of what the distribution is. But we have a lot more data within the hospitalized setting. And in the hospitalized setting, certainly in the US, there does seem to be an imbalance, and that imbalance is more dramatic in critically ill individuals. I cannot imagine that there's not going to be a biological rationale for that. And so I think some of the components that you've described regarding ACE2 and ACE2 processing and signaling has to be reflected, or has to be influencing what we're seeing in terms of disease severity and clinical manifestations. And so the fact that you're doing that work, I'd encourage to collaborate with some of the folks over here that are doing some similar work so that we can generate data relatively rapidly. The same component comes to the issue of obesity. Obesity, certainly in the US, seems to be very strongly linked with negative outcomes. And so I would again suspect, maybe for the same mechanism, that there will be a mechanistic reason for why that's the case. All of those components that reflect mechanisms and provide biological insights, as you can imagine, I don't know who you can because you've done this, will be reflected in targeted therapeutic strategies. That to me has to be the aim that we have in the future.
Thank you very much, Dr. Martinez. I think one of the very early conversations I had regarding ACE2 was with a colleague who said, well, the solution then is to put everybody on an ACE inhibitor. But I think it might be more complicated than that, because the hypertension signal would suggest otherwise. I suspect that the hypertension-associated mortality figures would point us in the direction of a group of people who are already on ACE inhibitors, and therefore perhaps potentially upregulating their ACE2 expression by negative feedback, which would perhaps make them more vulnerable in some way to COVID infection. I don't know. Again, these are all very sort of limited hypotheses, but we have bantered, we have discussed a lot of different ideas in terms of the mechanistic biology behind this, as you say.
Well, listen, when I walk to the ICU every day, I wonder whether I should be taking my ACE inhibitor or not. So it's a very practical component.
Thank you, Dr. Martinez. That's you and me both in practice, actually. I do wonder if ACE inhibitors are sort of influential, at least in this context. I'm going to move forward to talk to Professor Mike Grocott in Southampton about treatments in the intensive care. Now, we've moved past the early stages, Professor Grocott, with hydroxychloroquine and Kaletra. I remember early discussions with my colleagues in Shenzhen about using lopinavir and ritonavir. And we are concluding that none of these agents independently work very well or very clearly in all critically ill patient groups. So what are your thoughts about the inflammation that you described and the discussion about where we need to go with this? Do you have any sort of thoughts on where we might direct our energies and trials?
Yeah, I'm not sure I have any answers. I think we need to have attention to the critical care interventions that we are providing. So I think thinking carefully, not just about drugs, pharmacology that will modify inflammation, but also the consequences of, for example, ventilatory strategies in terms of driving inflammation. We know about ventilator-induced lung injury, but there does seem to be a bit of a flavour from different groups who are either strong protagonists of avoiding ventilation through quite persistent use of CPAP, and others who are, as you will know across London, the different groups, other groups who are very keen to go for intubation early and avoid non-invasive ventilation. And both argue that there's a potential pathophysiological basis to what they're doing. So I think there's some interesting questions there. I think some of the things that we've previously discarded in relation to management of lung injury and ARDS may have a role. So I'm thinking of things like surfactant therapy and nitric oxide therapy, and we have a direct interest in both of those, but nitric oxide particularly interesting because it potentially has direct antiviral effects as well. And it's clear that so far we have no magic bullets. So I think we're going to be looking at all aspects of care, including antivirals, different approaches to immune modulation and anti-inflammatory pharmacology, and then being very careful about all the other things we do to minimize promotion of inflammation.
Thank you very much, Professor Grocott.
Yeah, I think, well, I would like to make a...
Please. Hello? Please. No? As an extension of that, Professor Grocott, I just wonder, we've all seen the benefits of prone ventilation in certain of these groups of patients, and I think I'm certainly more and more convinced that this adds a ventilatory benefit. What are your thoughts on this, and in terms of the nature of the gas transfer deficit and the lung ventilatory mechanics on intensive care? Are we looking at really sort of a policy or universal sort of approach to these patients who come into intensive care?
So practically, despite being a little skeptical early on, we are proning almost all of our patients now. And what we're typically seeing is that there's a variability in response to proning, but typically they respond better early. So we would go for 3 spells of 16 hour with an 8-hour break. By the time we get to the 3rd spell, quite a few patients seem to be not responding as they get a bit sicker. We're having a lot of, we feel, and clearly there's not clinical trial, but experientially it feels like the conscious proning, so patients who are self-proning themselves on NIV, which is, if I'm frank, something I have not thought of before and I haven't come across before clinically, but we've adopted from others. And the patients seem to really like it. They seem to feel more comfortable, and some of them can sleep like that. And then my impression is we may be avoiding intubation through that approach. But it doesn't seem to be as helpful once we get more advanced illness.
I mean, certainly here at the Royal Free in London, we're also proning many of our patients, probably the vast majority of them, and we're very grateful to our surgical team headed by Bimbi Fernando, who has been sort of leading the proning teams going around ICU. Obviously, this is very labor intensive, and so we've drawn everyone in the building in to help with the proning operation, as it were, and that's a separate on-call rota almost entirely.
Yeah. I mean, we have the same. It's a huge logistical challenge.
It is a huge logistical challenge. I'm going to move on now with the next question because we only have a few minutes
left. Can I make a point? Please?
Yeah, please do.
Can I make a point?
Yeah, please do.
Oh, sorry.
Please do.
Can you hear me?
Yes, we can. Okay.
Can you hear me?
Yes, we can. Can you make?
Yes, just make a point, very brief. So I quite agree with what Mike mentioned about the. I think the most common involvement of the other than lung as the kidney. I agree with that. So you had mentioned about your involvement complications about 20%. From our data, from the critical ill patient with more than 400, so about close to 40% of patients with different extent of kidney, the basic necrosis of kidney tubules. So that's why we suppose. So sometimes if we can see the tendency of the deterioration of the liver function, CRRT should be putting on as soon as possible. Thank you.
Thank you very much, Professor Zhong, for that very clear summary. Moving on to the next questions, I think we'll draw on our experience of our colleagues in Shanghai, Professor Chu and Professor Zhang. If you could share with us, in your experience, there have been a lot of questions from Japan and Spain here, where the clinicians locally are asking about the benefits of tocilizumab, so anti-IL-6, and the targeted sort of anti-inflammatory agents. Firstly, they question how and why we think it might work, and whether or not, in your experience, with perhaps larger numbers as a denominator, you think there's value in pursuing these directions of therapy.
Professor Zhang, could you answer this question firstly?
Professor Zhang?
Yeah, so you want to answer give a question about IL-6, yeah? Yeah.
Yes, IL-6 and IL-1. Yeah.
I did not hear very clearly.
Sorry. Just to repeat, that it's for tocilizumab and IL-6. Do you think this improves the prognosis of patients with severe viral pneumonia?
Yes. I mentioned that in some sites in China. My colleagues use it in Wuhan, the epicenter of China. There are some cohort there. They compared there with the other therapy. So we can see that the outcome may be better than the control. However, in Shanghai, because we only have 600 to 700. We just use some cases here. However, I think, of course, by the safety of this this agent is good. However, we do not think it's just like I mean just like improve the symptoms very quickly, or just can be stop the faster progression of the disease. So recently we just use that in very ill patients. So according to my experience in Shanghai, not so many experience, and also some data from my colleagues in other cities. Up to now, I cannot recommend it as the first line of the therapy for my critical ill patients. So this is my opinion recently. Yeah.
The paper about the IL-6 receptor antibody will be coming out soon. So there are two viewpoints inside China. One is only in those patients with enhanced IL-6 can be an indication of that. The result seems to be promising. The other point was, if you have some cytokine storm, So IL-6 receptor antibody should be used, but I don't think there's so many positive evidence showing that. Okay.
Yeah, so I totally agree with Professor Zhong's comments about the therapy of the IL-6 receptor antibody, Rezibam. So just according to the experience of the Wuhan and other cities of China, we just use for the patients with the measurement of the IL-6 level. If the IL-6 level is quite high, maybe this clinical efficacy is good. So I think it's maybe we should do this at once.
Thank you very much. And just to extend on that, there's an outside question here from Serbia. They're asking, did your experience in China or in Europe, I think they're asking here, extend to using agents such as non-steroidal anti-inflammatories? So what are your thoughts on using ibuprofen, for example, or the COX inhibitors for COVID-19 positive inflammation? Do you feel there's any benefit in using non-steroidals?
Yes. Some of the small groups have been doing some inhibition of COX-2. So that kind of pain killing is at that. And then because they have measured the urine prostaglandin metabolites is pretty high. So that's why they use this. It seems to be useful in relieving the symptoms, in particular high fever, of course, and other symptoms. In the early stage, their conclusion may be positive in using this kind of agent.
Thank you very much, Professor Zhong. May I direct the last question here, I think, to Dr. Martinez and Dr. Wong in Hong Kong. Just very quickly, this is a question from Hungary. We learned about diabetes as a comorbidity associated with worse outcomes in COVID-19. Do you feel that it's worth investigating the effect of glycemic status in diabetic patients? And what are your thoughts in your experience in New York, Professor Martinez, with the diabetic and perhaps overweight population that you see?
Yeah, no,
I assume they're talking about type 2 diabetes here, but we haven't seen very many type 1s, interestingly.
Actually, if you come to our ICU now, we have 3 DKAs in the ICU that are actually COVID infected, so it just goes to show. And so I agree completely. I think that from a mechanistic point of view, the link between obesity and diabetes, which actually holds in multivariate analysis, suggests that there's likely going to be an important biological and a plausible relationship. The management or the assessment of glycemic control is something that has been studied intensively in the ICU, as you guys realize, in critical care with varying results. I think that area is an area that is very, very important from an investigational perspective. And when I give a long-winded answer to a very good question, it generally means I have no clear idea. And it requires your insights and systematic collection of information to be able to address.
And Dr. Wong, do you see any signal for diabetes in the young, perhaps with the type 1 diabetics?
Not at all. And of course, the majority of cases have occurred in the early period. They were in China, and type 1 diabetes in children in China, it's very rare. The prevalence is about 1/20th of what people see in the Scandinavia and the UK. So there is no signal there. But one special thing. Yeah, but one special thing would be actually, in general, asthmatic would develop attack precipitated by virus, but there is no signal in the disease in children that none of the cohort in Wuhan Children's Hospital, they have underlying asthma. And in general, also the children do not present with wheeze. The disease primarily is in the lung parenchyma and the airways are spare.
Yes, no, I very much echo that. I mean, we've seen the same diabetic sort of profiling of patients here, obviously, and there have been quite a few DKAs, as Professor Martinez has mentioned already. We haven't seen very many type 1 diabetics, but again, as you say, that might be because of sort of background prevalence rather than anything else, or perhaps there may indeed be a difference between type 1 and type 2 diabetes here. I am just going to extend, because we've caught up a little bit, just in terms of a last question. What does the panel of experts believe or think about the sort of the associated coagulopathy, or the sort of thromboembolic phenomenon that we're seeing? Because in the last few weeks in London, I've seen a lot of subsegmental sort of embolization of the lung, and if you look on the CTPA, they are at the second, third, fourth order vessels, branch vessels at the periphery, almost just to the limit of what CTPA is able to resolve. And it's very interesting to us, because obviously there's this whole discussion about higher lines thrombosis, the sort of immune complex deposition, or whether or not there's a sort of inflammatory response that drives this apparent sort of predisposition to local thrombus in the lungs. We did 3 CTPAs upstairs, I think it was day before yesterday, and 3 for 3, they were all positive. So as an anecdote, what does the panel feel is the background to this, and how can we treat this better?
I would agree. There seems to be an increasing signal that this is a coagulopathic, or even vascular coagulopathic illness, at least in part. And we've had a similar experience in our hospital and adjacent hospitals in terms of much higher incidence of PEs. When we're doing the CTPAs, they're much more likely to be positive. There seem to be quite a few thromboses generally, in terms of line-related thrombosis, that kind of thing. And we've definitely shifted everybody, if you like, right a bit. So we're giving a higher level of thromboembolic prophylaxis, and we're focusing much more attention on that. And in those patients who are properly sick with multiple organ failure and either a high or a rising D-dimer, we are formally anticoagulating with an APTTR target of about 1.5 to 2. And that I think is becoming more common. We'll see if it is of benefit.
Not same in the US. The other thing we've seen is a lot of problems with renal replacement, cartridges clotting off and lines clotting off, and it's become much more of a challenge for our nephrologists to be able to appropriately do renal replacement in this setting. There's clearly, in a fraction of individuals, an impressive hypercoagulable state.
Right. No, so this is a consistent signal. And Professor Chu and Professor Zhang, Professor Zhong in China, do you feel the same way about patients?
I think the micro thrombosis in the lung is a big problem. So and also we can see some of the patients with massive hemoptysis with complication. Actually, they very high titer of D-dimer. And then, so that's why some of the hospitals, they try to use low dose heparin to treat those patients. But anyway, there's any control studies. But I think as compared with other kind of ARDS, it did play an important role in the pathogenesis of COVID-19 infection.
Thank you. I think, as Mike says, we are setting a very low threshold now for screening, because obviously if you don't look, you don't find. So we screen more regularly, and the other thing is also we're treating with a lower threshold and perhaps with a slightly higher level of anticoagulation support with these things in consideration. I think this is affecting or impacting our clinical practice in all these directions. I'm going to invite each of our panel of experts now to give us a final comment for what they feel is the most important direction to take this forward. So starting with Professor Zhong again, if you'd like to share with us some final parting comments before we move on to the subsection conferences.
Well, very interesting discussion. As I mentioned before, the quality is improved once by once. So this time, I have learned a lot of experience from others. So I suppose next time we'll have more concern about the mechanism and then the immunoresponse about this kind of research. So rather than just thinking about the clinical trial or some others. So this is because it's a long run. I think, I suppose that Professor Martin mentioned about it's a marathon, not a sprint. I quite agree.
Share with us some final or key thoughts about where you'd like to see this.
Yeah, I won't take Grokat's marathon line. That was his line, which I would love to say came from me because it's a great line. And as I've told all of my colleagues here at our institution, this is a problem that isn't going to go away. It is a problem that will not be resolved purely by epidemiological studies. And it is not a problem that's going to be resolved by anecdotal experience. This is going to require a combination of very good epidemiologists. There's certainly some on the line. Christopher, people who have a good understanding of translational biology. That's going to be crucial to be able to link and define mechanisms. And then finally, a coordinated, integrated approach between multiple investigative sites across the globe, with partnering with societies, with their own federal governments, and, Pascal, you're still on, with industry, to be able to define appropriate therapeutic strategies based on the combinations of the epidemiology, clinical observations, and the biological constructs. This is the perfect model of what that type of an approach is going to be vital for us to be able to get a control of this challenge.
Thank you very much, Professor Martinez. And as you say, as we stare down the barrel of this new normal, I do reiterate the science paper. I'd like to share it with everyone by Stephen Kistler and Mark Lipsitch on projecting the transmission dynamics in the post-pandemic period. I mean, I think this is something that's foremost on everyone's mind, and we need to see how this pans out, because obviously there is the potential for transmission in cycles now once it's established in the population. So we do have to be very careful about how we proceed, and perhaps develop the science and the data to support policymakers in their very, very difficult decisions.
Better said than I could have said.
Thank you. Professor Grocott, please.
I think I would make 3 points. One, I think it's going to be an enduring challenge, and I'm not a great fan of the military analogies, but I think it's going to take our combined efforts to fight, and I don't think we're ever going to defeat, but to come to some kind of living arrangement with this virus. And I completely agree with the comments about coordinated research. My second comment would be we do need to, we're all very lucky speaking from positions of relative wealth globally, and I think the consequences from some of the poorer countries may be terrible, and attention to the types of interventions that could be effective in those environments I think is very important. And finally, as physicians and as healthcare workers, the personal is going to be very important. It's going to be a very challenging time because of all the social consequences of COVID, and it's very challenging, the different ways of working professionally. And I think the professional compassion is going to be a very key element.
Thank you very much, Professor Grocott. I think perhaps really what we're looking for is some sort of entente cordiale with the viral, the enemy, as it were. I'm moving on to Professor Chu then, and Professor Zhang in Shanghai. Could you share with us your final thoughts on where you'd like to see things go from here?
Yeah, I think it's during the past 2-3 months, just we knew about the COVID-19 gradually, especially I think it's for the virus and the physiology. I think it's another very big challenge. Up to now, I think we just only familiar with very little for COVID-19. So actually, we should do a lot of things, stop the spread of the COVID-19, just like public prevention policy or strategy. Just another very important thing is we should further investigate the pathophysiology of the COVID-19. Then we can find very precise and the effective and the target therapy for COVID-19.
Thank you, Professor Chu. I think we would echo that. There are many of us who believe that in the absence of any effective therapy, falling back to the first principles of infectious diseases management, which is to identify, test, isolate, and then treat, is the right way forward, absolutely. And I do fall back on first principles in these very difficult times. Professor Zhang, please, if you'd share with us your thoughts.
Yes. I think now the way for controlling the disease, I think, is so far away. So I think it's much longer than marathon itself. But I feel very lucky this time. We fight against the virus together this time. Not only China fighting against the virus. So because today we learn lots from our colleagues from other countries. So I think next time we can share more information about the virus. Even though today we do not know where is the vaccine, where is the promising agents, but I think maybe not far away that we will have it. So I hope that next time we will know more about the virus and we have more agents and more strategy to fight the virus. I think we will win in the future. Yeah.
Thank you, Professor Zhang. I think we're going to have to ask Pascal and our support structures, our industry partners to help us here. One of the things that comes to mind is that the last 3 webcasts we've done have grown in size, but also we always inevitably run out of time to share more and in depth in terms of our data. I suppose the other problem is we're so busy doing that we don't have time to undertake the necessary analysis. And I'm sure we all struggle with that. But you're absolutely right. I think there needs to be more sharing, and we need to make this open. I think perhaps if Astra can consider setting up some sort of platform to link everybody together after these 3 meetings, we should stay in touch and really open the channels of communication widely to ensure that we have free transfer of information and the necessary research and data sets to support everything. Professor Gary Wong, please. Gary, are you there?
Yes, I'm here. Yes, and as far as the role of children within this disease is concerned, we really need to figure out, the large number of these mildly affected children, asymptomatic children, as well as the young people and the adolescent. What is the role in terms of spreading the infection in the community? And of course, we need to understand the biology, why the disease behaves so different compared to adults. And we must not forget, actually, on top of all these children that we need to look after, there are millions and millions of children now, they are not allowed to go to school. They are locked up in the home. The psychological effect and the detrimental effect on their learning. And we must pay attention to that too, until there are effective vaccines to protect people.
You're absolutely right. Unfortunately, vaccines appear to be a good few months away, if not a year down the line or more. And I think we do forget the social and psychological impacts of these decisions. I mean, basing it on the science and the data is very good, but certainly we need to consider the impact on children, and certainly with the numbers that you've seen already, there is a clear signal coming through that we need to pay attention to. So we'd be delighted as adult physicians to work with our pediatric colleagues to drive this all forwards. Unfortunately, in the interest of time, we did have prepared a polling section, but we're going to skip through that now to the closing remarks, because the section seminars are now prepared and ready to start. So it remains for me to thank each and every one of our panelists, Professor Zhong, Dr. Martinez in New York, Professor Grocott in Southampton, Professor Zhang and Professor Chu in Shanghai, and Dr. Wong, Professor Wong in Hong Kong. Thank you very much for your time and your sharing. I hope we can really take this forward now. We've had 3 meetings to date. They've all been very similarly successful, and we really need to merge these ideas and discussions into something more solid now, perhaps in terms of the data and the science, or driving forward some of the discussions on policy. We have to thank also AstraZeneca and Pascal for their incredible support in coordinating this very timely and meaningful event. So thank you to Pascal and his entire team at AZ. They really should be applauded for taking the lead on this. We wish everyone here, including all our partners in industry, success in our individual and respective fights against COVID. This section of the webcast has now ended in the interest of time. You will be directed on your screens now to select one of 3 breakout sessions covering specific areas of interest in the context of COVID-19 under the headings of respiratory medicine, cardiovascular disease, and oncology, and I'll hand you over to their hosts separately. So thank you very much for joining us today. Bye-bye.
Thank you for your leadership. Thank you.
Thank you.
Thank you.